So this is part 2 of section 9.4, products to sums and sums to products. And on this part, we are going to look at sums to products. And again, without going through the derivation of the formulas, I am going to look at how to get the sums to products. So the sine of A plus the sine of B is equal to 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. The cosine of A minus the cosine of B is equal to negative 2 times the sine of A plus B over 2 times the sine of A minus B over 2. Then the sine of A minus the sine of B is equal to 2 times the sine of A minus B over 2 times the cosine of A plus B over 2. And then finally, the cosine of A plus the cosine of B is equal to 2 times the cosine of A plus B over 2 times the cosine of A minus B over 2. So let's look at a couple of examples of this. And the directions on here are going to be exactly this. Write the following difference of signs expressions as a product. So it's either going to say sum or difference to a product. And so problem number 1 says the sine of 4 theta minus the sine of 2 theta. So I look up here at my top equations and I look for where I am taking both of them are sines and they're being subtracted. So this is the sine of A minus the sine of B. That's what I have here. So A is 4 theta and B is 2 theta. So this is going to be using this formula. I'm going to have 2 times the sine of A minus B. So that would be 4 theta minus 2 theta over 2. And then times the cosine of A plus B over 2. So that would be 4 theta plus 2 theta over 2. So this gives me simplifying. 4 theta minus 2 theta is 2 theta over 2 times the cosine of 4 theta plus 2 theta is 6 theta over 2. So this gives me 2 times the sine, and the 2's cancel, of theta times the cosine, and then the 2 goes into the 6 3 times. 3 theta. So that's how you write from a sum or difference to a product. Okay, let's look at another one of these. Let's say problem number 2. We have the cosine of 15 degrees minus the cosine of 75 degrees. And I want to see what that's equal to. So I look up at the top and I'm looking for the formula that has cosine of A minus cosine of B. So cosine of A minus cosine of B is equal to negative 2 times the sine, I don't really need these parentheses, the sine of A plus B over 2. So that would be 15 plus 75 degrees over 2, and then times the sine of A minus B. So that would be 15 degrees minus 75 degrees over 2. And so this is going to be negative 2 times the sine, and if I add these, I get 90 degrees over 2 times the sine, and this would be negative 60 degrees over 2. So this is going to be negative 2 times the sine of 45 degrees times the sine of negative 30 degrees. So now let's look at these two triangles, because these are two triangles that we know. So for 45 degrees, looks like this. And we have 1 square root of 2. So the sine of 45 is 1 over the square root of 2, because it's opposite over hypotenuse. Now, for a negative 30 degree angle, that's going to be in the fourth quadrant. Here's my reference angle is 30 degrees. And again, the 30 degree angle is opposite. It's a smaller angle, so it's going to be opposite the smallest side. And so that would be 1, 2, and square root of 3. But we're not in the first quadrant anymore. And so something is negative. And what's negative here? Well, I'm going in the positive x direction, but the negative y direction. So this is going to be negative 1. So that would be opposite over hypotenuse will be negative 1 over 2. So now notice that the negative and the negative will cancel, and the 2 and the 2 will cancel. So my final answer is just 1 over the square root of 2. So if they give you numbers that you can work with, and it's numbers that are angles that we know, then what we're going to do is we're going to use those and get an answer with a single number instead of in terms of theta. Now, we can also use these sum to product or product to sum formulas to verify identities. So I'm going to go to a new page on this one, because this one can be kind of long. So here I'm going to have problem number 3 says the cosine of 4t minus the cosine of 2t divided by the sine of 4t plus the sine of 2t. And I'm going to show that it's equal to the negative of the tangent of t. So the first thing that I'm going to do is I'm going to look at my sum to product formula. So sums to product, I've got cosine of A minus cosine of B. So cosine of A minus cosine of B is equal to negative 2 times the sine of A plus B over 2 times the sine of A minus B over 2. So the numerator is going to be negative 2 times the sine of A plus B over 2. So 4t plus 2t over 2. And then times the sine of A minus B over 2. So here A is 4t, B is 2t, so that would be 4t minus 2t over 2. So that's my first one. This denominator here is the sine of 4t plus the sine of 2t. So again, I'm going to look at my sum to products formula, and I'm looking for the sine of A plus the sine of B. So that's this one. So it's 2 times the sine of A plus B times the cosine of A minus B over 2. Excuse me, sine of A plus B over 2 times the cosine of A minus B over 2. So this will be 2 times the sine of A plus B over 2, so 4t plus 2t over 2, times the cosine of A minus B over 2. So that would be 4t minus 2t over 2. And I want to show that that's equal to negative tangent of t. So now let's simplify what's in the parentheses. So you get negative 2 times the sine of, this would be 4t plus 2t would be 6t over 2, times the sine of 4t minus 2t would be 2t over 2, divided by 2 times the sine, and again 4t plus 2t is 6t over 2, times the cosine, and again 4t minus 2t is 2t over t over 2. So now I want to simplify that. And so reducing these fractions in the parentheses, I get negative 2 times the sine of 3t times the sine of, the 2 goes into 6 3 times, 2's cancel, so I just get t, over 2 times the sine of 3t times the cosine of t. So now let's see what we can cancel. Notice I can cancel my 2's, and then I also have the sine of 3t and the sine of 3t that will cancel. So now I'm left with negative sine of t over cosine of t. And what is sine of t over cosine of t? From originally when we first started looking at these, that's equal to the tangent of t. So this is equal to the negative tangent of t. And that is what we were trying to verify. And so it is verified. So that's problem number 3. Now let's look at verifying an identity formula using the double angle formulas. So this one says, I'm not sure why they put this one in this section, but we'll go ahead and work it. It says the cosecant squared of theta minus 2 is equal to the cosine of 2 theta over the sine squared of theta. Now, remember, we have 3 different formulas for the cosine of 2 theta. The cosine of 2 theta can be equal to the cosine squared of theta minus the sine squared of theta. Or it can be equal to 1 minus 2 sine squared of theta. Or it can be equal to 2 cosine squared of theta minus 1. Now in this case, look what we're trying to get. This is 1 over sine squared of theta, and this is just 2. So notice, since I'm dividing by the sine squared of theta, it will be simplified the most if I use this second option for the cosine of 2 theta. So this is going to be 1 minus 2 sine squared of theta over sine squared of theta. Now, the sine squared of theta is divided into each one of these, so I'm going to separate it into 2 fractions. 1 over sine squared of theta minus 2 sine squared of theta over sine squared of theta. And so this is a reciprocal identity. This is just 1 over the sine is the cosecant. So 1 over sine squared is cosecant squared of theta minus 2. And again, it's equal to what we wanted it to be. So now we have verified the identity. So that finishes up section 9.4. I do feel that this one is a lot easier than most of the other sections. But again, if you have trouble with it, we will be doing some conference calls to answer any questions that you might have.